Hi everyone. In this video, let's solve Leetcode problem number 11, container with most water. The problem states that given an integer array height of length n, where all the elements are vertical lines drawn such that the two endpoints of the ith line are I comma 0 and I comma height of I. We need to find two lines that forms a container with the x-axis such that the container contains the most water. We need to return the maximum amount of water a container can store. For example, for this input array, the answer is 49 because we form a container with height 8 and height 7. And the water cannot flow beyond height 7. And hence the area of this shaded region from this example is 49, which is coming from the minimum of two heights, 8 and 7, and the distance between the two bars. So in our example, the 8 is having an index 1 and 7 is having an index of 8. And hence the distance between these two bars is 7 and the minimum of the two heights is again 7. So the height of the shaded region in the example is 49. Let's take two random bars from this graph and try to understand the problem before we solve the problem. Now, this is my input height array from the first example, and the bottom row just points the indices of different elements of the array. If we plot this in a graph, this is how it is going to look like. Now let's randomly pick two bars from the input. Let's pick these two. And if we were to form a container between these two heights, how much water can we add into the container? Let's fill the container with water and see how much the container can hold, after which the water is going to flow out of the container. So as we start filling, we notice that the water can reach a height of 4, after which it is going to flow out of the container. So the max height of this container with which we can fill water is going to be 4. And the distance between these two height is the distance between the corresponding index, and that is 5 minus 2. Now, if we were to find the area of the shaded region, we need to just multiply the width and the height, which is going to give the area of the container. And in our case, the width is the distance between the two index, which is 5 minus 2, and the height is the minimum of 6 and 4. In other words, this is how we are going to find the area of water within the container. So the area of water within the container is going to be distance between the two indices and minimum of the height. So in this example, it is 5 minus 2 multiplied by 4. So 3 times 4. The area of this container is 12. Now let's take another example. Let's take these two heights, and we know from previous example we cannot fill water more than the minimum of these two heights. So if we fill water inside this container, we cannot go beyond height of 2, after which it is going to flow out of the container. Now the area of this container is going to be the same width into height, and the width here is 7 minus 3, which is 4, and the height will be minimum of 3 into, that is 2. So the area of water within this container is going to be 4 into 2, which is 8. Now that we understand the problem, let's see how we can solve. Let's go back to our input graph. And to start with, we are going to solve this in a brute force approach. The brute force approach is going to be considering all the different combinations of heights, calculate the area of water within all the containers, and then find the max among them. So we will have our right and left pointer pointing to the first two elements. Now we are just going to find all the combinations of containers of our input array, and then we are going to just calculate the max. So for example, if these two are my heights of the container, we know that water cannot flow beyond the height of 1, which is the minimum of 1 and 8 in this example. So if I fill water, I will have water up till this point, and hence the area of this container is just going to be difference between the index and the minimum of 1 and 8. The minimum height in any example is just going to be our limiting factor, which is going to limit the height of our container. So no matter how big the other height is, the shorter height of the container is always going to limit the height up to which we can fill water. So in our case, this example, the limiting factor is 1. So the second height, which is of 8 length, irrespective of what height it is, even if it is 100, it doesn't matter because we cannot go beyond 1, and 1 is our limiting factor here. The area of this container is just 1 because the width is 1 and the minimum height is 1. And since this is our first container in the brute force approach, the max area at this point is just going to be 1. And we move on, we move the right pointer to the next height. Notice that since 1 is our shorter of the two numbers, it doesn't matter how big the other height is. The height of the container is never going to exceed 1. As I said, 1 is the limiting factor here. And the area of this container is 2 just because the width is 2. The height didn't change, but the width is 2, and hence the max area is 2. And we move on. Now again we increase the width, but the height never changed. As always, 1 is the limiting factor. Since it is the smallest of the two heights, the height is never going to go beyond 1. The max area is 3 because it is more than the previous max area. So we update the max area and move to the next height. And the width is 4 now, and hence the area is also 4. And we update the max area because it is more than the previous max area. We proceed to the next height, and similar to the previous examples, now the area has gone up, so we update the max area. As we slowly move towards the next elements in the input array, you can see that the area is increasing just because of the width is changing, but the height never changed. So once we reach the final element in this cycle, the area that you see is the best that we can do by keeping the first element as part of the container. In other words, if we were to form a container with height 1 and any element in the array, this is the best that we can do in terms of max area. Now we proceed to the next round where we move the left pointer to the next index and then do the same experiment. Notice that now we have a bigger number. The height is going to change as we move the right pointer. In this particular example, 6 is the limiting factor. The height of the water cannot move above 6. Otherwise it is just going to flow out of the container. Now the area here is 6 because the minimum of the two height is 6 and the width between the two height is 1. But it is still smaller than the previous max area, so we are not going to update the max area. We are just going to update the right pointer. Now the right pointer points to a height of 2, which becomes our limiting factor here. So the water cannot go above a height of 2. And the area of this shaded region is just 4 because it is the width differs by 2 and the minimum of two heights is again 2. So the area is 4, which is smaller than the max area. So we are not updating the max area. We are just moving on. We are updating the right pointer. And now, because we have a height of 5, which is the limiting factor, the area suddenly becomes 15, which is higher than or larger than the previous max area. So we update the max area. We update the right pointer to point to the next one. And as you can see, this is larger than the previous max area, so we update the max area. The height is 4 because that is the least of the two heights, 8 and 4, and we multiply that with the difference between the two indices, which is 5 minus 1, and hence the area for this shaded region is 16, and we update the max area. We proceed further by updating the right pointer. Now we have a max area of 40 because both the heights are same. We can fill the container up to 8, and the difference between the width is 5. So the max area at this point is 40. And we continue, we update the right pointer, and now we have a height of 3, which is the least of 8 and 3. And the distance between the two indices is 6. So the area is 18, but it is smaller than the max area. So we don't update the max area. We proceed to the final element in this cycle. Now we see that the area is 49 because the difference in width is 7 and the least of the two heights is 7. And this is the max until now. So we update the max area. Let's take one more cycle to bring out the point, and then we'll see how we can implement this. So now we are done with the container starting from the second element of the input array. So we update the left pointer as well as the right pointer. So this is similar to how we calculated the area of water in previous example. So the area is the difference between the width and the least of the two heights, which is 2 in this example. So the area is 2, and we update the right pointer. Now the area is 2 times 5 because the difference between the width is 2, which is 4 minus 2, and the least of the heights is 5, minimum of 6 and 5, which is the area is smaller than the max area. So we don't update the max area, we just update the right pointer. And now with this example, the area is 12. Let me complete the full cycle for this particular container that is starting with 6 as one of the heights of the container. So as we complete this, you can see that the height of the container is always going to be the minimum of the two heights, and the width just increases by 1 with every time we move the right pointer, and we calculate the area appropriately. The time complexity of this brute force solution is going to be big O of n square, because we are going to have two for loops. The outer loop is going to control the left pointer, and the inner loop is going to control the right pointer. The inner loop will be incremented by 1 at each step until it reaches the end of the array, and the outer loop will be incremented by 1 every time we complete a cycle with the inner loop. At each step, we are just going to calculate the area by multiplying the width, which is the difference between the two pointers, and the minimum of the two heights. Every time we calculate the area, we compare the area with the current max area. If it is larger than the current max area, we update the max area. Let's quickly see how we can implement this. Let's create an integer variable to hold the result or the max area. This is what we are going to return once we are done with our calculation. So let's initialize this to 0, and then we'll start the outer loop. This is going to control the left pointer, and this loop is going to run until we reach the end of the array. This nested loop is going to control the right pointer. The right pointer's initial value is always going to be I plus 1 at the beginning of a particular cycle. So for any new value of I, j will start from its neighbor or the next pointer. So j's initial value is always going to be I plus 1. And we are going to run this until we reach the end of the array. And at each step, all we are going to do is compare the current area with the result and update the result if the value of the new area is greater than the current result. So this we can simply do it by using math.max and comparing result with the new area. Now the new area is going to be the product of the difference between the index, and the index's difference here is j minus I times minimum of the two heights. So minimum of two heights, nothing but math.min of height of I and height of j. Yeah. So this step we are calculating the area of the container, which is formed by height of I and height of j, and x-axis by multiplying the minimum of the two heights with the difference of the index. And once we have this, we compare the value with the result. If it is larger than my current result, we update the result. Once we are done, we are just going to return our result. This will return the area of the container with most water. Let's run the code to see if the two test cases pass. Okay, so for these input, the order of n square solution seems to be okay, but let's submit the code and see if it works for larger arrays. As expected, for larger arrays, the order of n square solution seems to exceed the time limit. So let's see how we can optimize our brute force solution. This is our input array, and the goal is to find the container with most water. So our goal is to find a container for which the width into height is maximum. The height is going to be random based on the input array, but the width, in order to maximize the width, we can always start from the first height and the last height. That is just going to give the maximum width possible, and then we can optimize for the height. So to start a sliding window approach, we're just going to have these two border elements into consideration. Let's forget about the intermediate heights for now. Let's start with the first and the last height of our input array. And we know that from the brute force solution, given any two heights, the shorter one is going to be our limiting factor. So for this example, with height 1 and 7, we know that if we want to form a container with a height of 1, this is the best that we can do. Because any other height, if we pick other than 7, we are just going to reduce the width, and we cannot get a better height than 1 because 1 is our limiting factor. So with these two heights, especially with the shorter one, this is the best that it can do. So if we were to form a container that includes the height 1, this is the max area that we can get for 1. And at this point, the max area is just 8. So we update the max area. And at the next step, we are just going to move either the left pointer or the right pointer. How do we decide? So we just move the pointer that points to the shorter height. That is because the shorter height is the limiting factor for our case. So irrespective of what the taller one is, we are not going to exceed the height pointed by the shorter one. So if we were to move one pointer to its neighbor, it makes sense to move the shorter one, because with the shorter one in the current state, this is the max we can do, or this is the best that we can do. Whereas for height of 7, we might find another height where the area can exceed the max area. So for height of 7, we are not sure at this point whether this is the max that it can do. So we should not move the right pointer for this example. But for the left pointer with the height of 1, this is the best that we can do if we were to form a container including height 1. So we're just going to move the left pointer because that's the shorter one and that's the limiting factor in our case. Once we move our left pointer to the next one, now we have an area of 49, which is better than the previous max area. So we update the max area. Again, we need to move one of these pointers to the neighbor. How do we decide? Like before, we are just going to move the right pointer now, because between 8 and 7, if we were to form a container that includes 7, this will be the best that we can do in terms of area. So we are just going to move the shorter height to its neighbor and see if we can exceed the max area. Let's move the right pointer because right pointer is the one which has the shorter or minimum of the two heights now. So once we do that, now we see that the area for this container is just 18, which is smaller than the current max area. Let's move the right pointer because that has the minimum of the two heights now. Once we move the right pointer, now we see that the area is 40, which is smaller than the max area. Now we see that both the heights are equal. Now which pointer to move? If both the heights are equal, we can move either of the pointer and see if we can identify a container with the max area. So let's move the left pointer. Like before, the area is just the minimum of the two heights multiplied by the distance between the index, which is 24 in this example, again smaller than the max area. So we're just going to update the left pointer because that has the smaller height. And we proceed because this area is again smaller than the max area. We're going to update the left pointer, which has the smaller value. And this container, again, it has an area of 10, smaller than the max area. So we proceed further by updating the left pointer. And now we see that the area is just 4 and the max area is 49 in our case. So the time complexity for this problem is just big O of n because we are just updating either the right pointer or the left pointer until the two pointers meet. And we started with the boundary heights, or we started from the first and the last element of the input array. We continued until both the pointers met. So the whole time complexity for this solution is big O of n. Let's see how we can implement this. Let's create a result variable. This is what we are going to return, and we'll first initialize this to 0. And let's have our right and left pointer. Left pointer is initialized to 0, and right pointer just points to the last index, and that is height dot length minus 1. Now I'm going to run this while loop as long as my left pointer is less than the right pointer. Okay, inside the loop, at every step, we are going to update the max area if the current area is larger than the max area. So max area is going to be math.max of itself and the product of difference between the width. Difference between the width is right pointer minus left pointer times minimum of the two heights, which is math.min of height pointed by my left pointer, height pointed by right pointer. So this is just going to update the max area if needed. And now we need to update either the right pointer or the left pointer. So how do we decide? We are going to update the pointer whichever contains the minimum of the two heights. So we are going to compare the two heights. If height of left pointer, if that is the shorter one, we are going to update the left pointer. So this will be, once we do this check, we know that if this condition is true, the height of left pointer is the shorter one. So we are going to update the left pointer. Or if that condition is false, we are going to update the right pointer. Now right pointer is moving in the opposite direction, so we are going to decrement right pointer. And once we are done with all these, we are just going to return our max area. Let's run this code to see if the two test cases pass. As you can see, the two test cases passed. Now let's submit the solution. I hope this was useful. Thanks for watching.